All right, here we are, the final explainer in our RAG Mastery series. Today's the day we build our capstone project, a really powerful code documentation RAG. We're going to pull together everything we've learned to build an AI assistant that can literally understand and explain any code base. So let's dive right in.
You know, every single developer knows this feeling. You get dropped into a brand new project, you're staring at a massive, maybe a million-line repository, and your first job is just figure it out. I mean, where do you even start? It really does feel like trying to find a needle in a digital haystack.
Well, what if you didn't have to read it all yourself? What if you could build an assistant that's already read every single line? It already gets the structure, and it can answer any question you throw at it. That's not science fiction. That is exactly what we are building today.
The vision here is actually pretty simple, but it is so powerful. We're talking about an AI assistant that you can point at any public GitHub repository. It becomes an instant expert on that code, getting you up to speed in, I'm talking minutes, not weeks. This is a total game changer for developer onboarding and, just maintaining code. And look, this is not just some simple search tool. It ingests the entire repository, and it uses this really cool technique called syntax-aware chunking, so it actually understands the code structure. This lets it answer complex questions, give you runnable code snippets, and, this is absolutely critical, it links you directly to the source on GitHub so you can see it for yourself and verify every single answer.
Okay, so let's pop the hood and look at the system blueprint. How do we actually go from a GitHub URL all the way to a smart, context-aware answer? Well, it all comes down to the data pipeline.
At a really high level, the pipeline is a pretty clear, straight line. We start with a GitHub repo, we clone it, we parse all the code files, we chunk them up into logical pieces, create vector embeddings for them, and then store all of that in a database. Once that's done, we're ready to take a query and generate an answer. So let's break that down.
We can really think of that whole pipeline in three main phases. First up is ingest, which is all about getting and processing the raw code. Second is store, where we create our searchable index. And third, the magic moment, is retrieve, where we ask a question and get a genuinely useful answer back.
Now, we've arrived at maybe the most important part of this whole system. The real secret sauce isn't just indexing the code, it's how we prepare it. And this is where syntax-aware parsing makes all the difference in the world.
So here's the crucial point. You just can't treat code like a normal text document. If you just split a file every 1,000 characters, you're going to break functions in half, you're going to completely destroy the context. Syntax-aware chunking, on the other hand, uses a special parser, something like TreeSitter, to actually understand the code's grammar and split it into meaningful, complete units, like an entire function or an entire class.
This whole process is powered by a function, let's call it parse Python file. Now, we're not going to go through it line by line, but its main job is to use TreeSitter to analyze a Python file. And TreeSitter doesn't just see text, it builds a full syntax tree, just like a compiler does. This allows it to pinpoint the exact start and end of every single function and class, so we can pull them out as these perfect, self-contained chunks.
And yeah, this slide just says it all, right? On the left, simple text chunking is a total mess. It's arbitrary, it's destructive. But on the right, syntax-aware chunking gives us these clean, logical units that keep the code's structure and all its context intact. This is the absolute key to getting high-quality answers.
Okay, so we've got these perfect, context-rich chunks of code. What's next? Well, now we have to index them in a way that lets us find the exact right piece of code at the exact right time.
And we don't just store the code itself. We store all this rich metadata right alongside it. So for every single chunk, we save its type, is it a function or a class, its name, the file it came from, its docstring, and even a direct URL to that code on GitHub. And that rich metadata is what gives our search superpowers.
To actually search all this data, we use a technique called hybrid search. And this is just perfect for code. Because, sometimes you want to search for a very specific function name, like clone repo. That's a keyword search. But other times you want to ask a conceptual question, like how do I connect to the database? And that's a semantic search. Hybrid search just lets you do both at the same time. It's the best of both worlds.
And the best part? With a modern vector database like Weaviate, actually doing this is incredibly simple. It's often just a single line of code. You just pass in your query and an alpha value to decide how much you want to weigh the semantic versus the keyword results. It's such an elegant solution for a really complex retrieval problem.
All right, we have built the pipeline, we have indexed all our data, and we've got a seriously powerful search strategy. So, let's see the payoff. Let's actually ask our system a real question.
So just imagine you're a new developer on the team, and you ask a pretty common question. Hey, how do I implement the GitHub integration?
And this is the kind of powerful, rich answer you get back. It's not just a wall of text. You get a clear explanation, you get a formatted code block that's ready to use, and, this is the best part, you get source citations that link you directly to the code in the GitHub repo. It is a complete, verifiable, and totally actionable answer.
And taking this from a local script to a real service your team can use is a pretty straightforward process. You just clone the repo you care about, run the parsing and indexing, and then you can build a simple UI or an API endpoint on top of it. And just like that, you've got a tool your entire team can use.
And with that final step, you've really seen how to build an incredibly powerful tool from the ground up. This project, it marks the end of our RAG Mastery series. So seriously, congratulations on making it all the way to the finish line.
That's right, 35 parts. That is a massive achievement, and it just shows your dedication to really mastering this technology.
I mean, just look at the skills you've mastered on this journey. You've covered the fundamental architecture of RAG, advanced document processing, embeddings, vector databases, all the way to semantic and hybrid retrieval, quality evaluation, and even production deployment. You now have the complete, end-to-end skill set to go out and build production-ready RAG systems with confidence. So we're going to end with a question for you. You've gone on this incredible journey. You've mastered retrieval augmented generation. The only question left is, what will you build? Thank you so much for learning with us.